Hello, everybody. Welcome to another Feeling of Computing workshop. Today we have Marek Rogalski, who will be showing us Automat, which is probably the most surreal visual programming environment that I've ever seen. If surreality is a trait that we can measure in programming environments, this one scores very highly in that regard. But I know just from past exposure to it that there are also a lot of interesting decisions in the semantics and in the lower level aspects of this system. And so it's not just a captivating thing to look at, it also has some very interesting ideas about how programming systems should work. And it's also one of those classic cases where this is being motivated by a really specific use case. So there's a really specific way that this environment is meant to be used and a specific goal for it that was, motivating the project, which I think is a really strong sign because it's not just programming kind of for programming's sake. It has a North Star that it is pursuing. And so that is, I think, a really interesting quality to pay attention to. So without further ado, I'll turn it over to Marek and we'll all take a look at Automat.
So Automat is a tool for playing games. I will get back to playing games later. It's not about playing games like The Witness, where the rules change throughout the game, but games are really not that important. What is most striking about it is the user interface. It uses some unconventional solutions. In some ways it's kind of weird, but in some ways it's also familiar. So I will try to explain why things are as they are, both in the user interface and underneath the user interface. So I like metaphors, and I will also take this opportunity to structure the workshop as a metaphor. So we are going to embark on a journey to the center of the Earth. The interface, this is the surface. We will spend most of the time here. I expect something like 30 minutes. Then we will descend into technology behind it. Vulkan pipelines, shadows dancing in the caves. And finally, we will arrive at the core, the computational model behind Automat stories. So let's start on our surface. Here I have Oblivion. I have been playing this game recently, and it has a fairly laborious progression system where to increase your damage, you have to keep hitting enemies, but you have to do it a lot. So instead of chasing monsters, you can find a stranger, somebody stoic enough to not mind if you just hit him repeatedly. And with a person like that, I can create a macro. The macro is going to press the left mouse button. It's going to wait some times so that the game registers a button press, and then release the left mouse button. And maybe I will wait a second between key presses. Maybe like that. I can even connect a hotkey to this macro. For example, to trigger this whenever I press F7. And now I have a macro. If I switch back to Oblivion, I can now hit this F7 key. And you can see that things have started moving within Automat. Those timers are moving the dials. There is a blinking in the cable, and my character is slowly leveling up. This will still take many hours to max out the combat skills, but what we can see here, this is the North Star of Automat, game automation. Most modern games are designed around a concept called game loops. Those are repetitive patterns that we as players perform. Over many repetitions, we get rewards. Progress in the game, like levels, gold, the story of the game is revealed. But we have to repeat those loops over and over. This is because of two reasons. Like, the first is classical conditioning, the Pavlovian theory of learning. Through repetition, we are trained to anticipate reward. This is what makes games fun to play, addictive. The second reason is pacing. Game loops are meant to slow down the player, otherwise the game could be finished very quickly. And sometimes those game loops can be pretty boring or annoying, and this is where Automat comes in. If there is a game you like, but it has some boring repetitive element, you can go ahead and automate it. You still get to enjoy the nice parts of the game, like you still get the same sense of progression and the same story will unfold, but without the grind. So this is the North Star of Automat. And just like in real life, North Star or Polaris isn't exactly aligned with the true celestial north. And for Automat, the true north or the true objective is to find a better way to make computers do stuff. Something that's simple and something that wouldn't require programming languages. Still, it's good to have a North Star because I'm very happy that I chose game automation because I don't get lost in the weeds. It makes the development more grounded in reality. So I'm not over-engineering the system too much because I actually have to automate some games. But enough looking at the sky. Let's look at the things that we have here on the surface. The key terms are board and toys. Toys exist on a board, a flat space, 1 by 1 meter, about the size of a table. You can customize the background of the board, so if you'd like, you can switch out the backgrounds. Here are some backgrounds I have used. Toys lay flat on this surface. The lighting is assumed to come from the other side of the table or the board. And all of the toys, they are rendered in an orthogonal projection top-down. This is because the environment could be viewed from many perspectives, and although Automat, you will mostly use it on a vertical display, on a screen in front of you, the design actually assumes a horizontal screen, something like an interactive table or a very large tablet. So if Automat is used on such a device, like an interactive table, many people could use and play with those toys. So the interface assumes it's multi-user. The alternative to the table would be a wall metaphor, but I decided not to pursue it because table seems like a better place to put toys than wall. So things in Automat don't hang, they lay flat. With one exception, those are fluids. So there are liquids. The behavior of liquids is actually not very interesting if you view them from the top. So there is gravity in Automat, but it only affects fluids. Now, scale. The whole environment is scaled to match real-world dimensions. When starting, Automat queries the display dimensions and resolution and makes sure that 1 centimeter on board is exactly 1 centimeter on screen. All toys are designed with this assumption in mind. All touch targets, text size, everything is designed to work just right at this exact scale. There is option to zoom in or out with mouse wheel. It's a very convenient way to move around. Middle mouse button can be used to drag the screen around. And if I press it, Automat is going to zoom in to its natural scale. Toys have shapes, and those shapes are important. Toys can be stacked on top of each other and moved together. If you click on a hole, it goes through. The toys don't register this. So shapes are used throughout the interface as trigger areas, drag and drop zones, obstacles and destinations for pathfinding. There is some cost to having fancy shapes, performance and maybe design difficulties. But the trade-off, as opposed to boxes, I could also wrap everything in boxes. But the trade-off seems to be worthwhile. It's quite liberating to be able to design things that are flexible and simulated. So there is that. Despite the irregular shapes, toys live on a grid. So they are always aligned to this millimeter grid, and they always have even dimensions in millimeters. So it's very easy to align them to left, center, or right. Yeah, any toy can be aligned with any other toy. This is an OCD-friendly environment. The design of toys, it relies on surrealism. Surrealism in art is it often relies on complex symbolism, and it's often hard to interpret without context. In Automat, the symbolism is shallow. It's meant to evoke dreamlike déjà vu, like the clock looks like an ideal clock from a dream, not just a number in the corner of your screen. The key, a keyboard key looks like a key, the mouse looks like a mouse, and so on. The second difference is that surrealist art tends to be unsettling, a little dark and scary. This is maybe an extreme example, but all surreal art, even Monty Python, has those unsettling and scary elements. Not in Automat. In Automat, it's used to convey this like perfect, idealized forms of objects in a pleasant way. So let's go over the toys that we have at hand. So toys are stored in this bottom rack. This is more of a temporary solution, but it's going to be convenient today. We will go through the toys from left to right. So when I pick a toy, one thing that happens is a black hole appears in the corner of the screen. I can use it to drop toys that I do not need, like I could even drop this whole thing. I can also right click on most toys and it's going to inflate a bubble menu. If I release the button, it goes away without doing anything. To activate an option, I need to move my finger and yeah, then it's going to activate. This way of interaction allows me to build muscle memory. The positions of objects are consistent, like middle mouse button, for example, is here. So I can very quickly select objects that I want to select. Delete is always on the upper left, move is always up. It's very fast to interact with toys like that. Bubble menu has one problem. It's not as discoverable. I would like all toys to be usable through their visual affordances rather than hidden options. So hiding those options in the menu is a design shortcut. I'll take it, but I try to avoid it. So some toys have cables. Maybe I can show a different one. The cables light up when control flow goes through them to indicate that something has happened. The decision to go with blinking cables was a major one, and there were a couple potential alternatives. The first one were pipes with water, and you can see in the user interface this metaphor of water filling different objects is still present. It's just a very old animation. The other idea was to have some actual roads, like in this carpet that some kids have in their rooms where they can play with toy cars. It would be like a tiny strategy game. Ultimately, blinking cables won because they capture the instantaneousness of actions and are kind of familiar to most people. I don't like those technical metaphors because I don't think they are as universal as something more basic based on, animals and natural world. The cables have one more thing. They arrange themselves in a very particular way. This arrangement is loosely based on the Dracon language. It is a way to visually represent workflows in ways that is easy to read. The Dracon kind of system is just a loose system. It's not Automat is not dogmatic about this, but it tends to push you towards this way of arranging things on screen. The cables have a little bit of physical simulation, but eventually they approach, if you just leave them alone, they approach a specific path that bends them into a sequence of straight lines and arcs. This is done to create a sense of order and tidiness and avoid spaghetti of Bezier curves. Something that typically happens if we just rely on polynomial curves. Okay, I was going to go through each toy in order. So switch. Do you know the term over-engineering? The switch is a design equivalent of over-engineering. The switch should have really looked like that, like that's the point of the switch. There is no need for yin-yang symbolism. It's a little bit confusing. In the past, switches have been pretty instrumental. They have been the main way of turning other toys on and off, but there is a better mechanism now, so I will show this other mechanism. It's still work in progress, so please excuse the pointless animation, but the animation is just for the debugging. When I have a toy, let's put a key toy here. This key toy can press a key, but it has also a property called monitoring that when I turn on, now it's going to react to my key presses. So when I press a key, you can see the finger is moving. I can synchronize the state of this key with a switch. And now, yeah, I knew something is going to go wrong. I knew it. Okay, let me delete everything and start from scratch. Yeah, now it works. So I can synchronize the state of the F key with a switch, and whenever I press F, the switch lights up. I can even synchronize the monitoring property. Actually, the switch actually has monitoring on, this is off, but well. Now I can, yeah, so now I disabled monitoring. I can enable monitoring and yeah. Answering the question on chat, yeah. So I can control whether the key is monitoring the state of the key by another switch. I can do fancy things with this. I can, for instance, synchronize the state of the key with a state of a mouse button. So I can create a machine, something like that, that's going to, whenever I press the F key, it's now pressing my mouse button. So I effectively hooked the F key to the left mouse button on my system. I'm not using the mouse, I'm pressing the keyboard key to move this object. The design of this sync mechanism is a reference to the image of gears that we see almost everywhere in, it's even here in iconography of settings on all computers. The metaphor of gears and timing belts is used as a way to convey synchronization. The belts are twisted. This is because I want to put some text here on those rubber bands, basically to have some labels between those objects, those toys. So this is the sync. Next in line is macro recorder. This is probably the only toy which is pretty much finished. It looks like a parrot because parrots have this ability to repeat after people. The iris is a reference to Naruto and anime, and it's another symbol for the ability to perfectly imitate someone else. Macro recorder is closely tied to timeline, and this toy is pretty essential. It can record a couple types of tracks, like 2D tracks for mouse movement, one dimension, like something like waveforms for the zoom, and on-off tracks for different keys being pressed. Tracks are pretty boring, except the 2D track. It has this ability to to chunk motion into meaningful segments. If I draw a couple of shapes, you can see that this 2D track, instead of showing each motion vector as a tiny arrow, it tries to chunk many of them, sometimes thousands. If I zoom in, you will see there's really a lot of them. It tries to chunk them into meaningful groups. Yeah, and this breakup algorithm is also kind of clever because it can identify straight segments of lines. So this way of visualizing things it's a reference to video editors and audio editors, they all like to put tiny thumbnails on tracks. And since Automat is mostly about macros, it has a very unique track type that also has its unique way to display thumbnails. Another element of timeline is the bridge. Bridge is symbolized by the color orange. It is used throughout the timeline design. The play button is orange because now it's moving by itself. The play button is orange because it's connected to the bridge. The current time is orange because this is the time at which bridge is positioned currently. The bridge is also the main way of editing timeline. I can use this manipulator here to splice a section or to elongate a section of timeline. The reason that cutting is attached to this bridge is because bridge is a start point of a splice operation, and when I drag it, I can perform a splice with a single mouse motion. So it's fairly fast. There is also a snapping mechanism. So when I move through the timeline, the fidelity of data points is actually very high. Those are nanoseconds. So it's very unlikely that I will ever hit exact point where some event happens. So there is a snapping mechanism. If you see there is this empty circle here, this means I am not snapped to any point, but when I point to this track, the bridge actually snaps now. So it actually snaps to different interesting points. This snapping works when I hover a specific track. When I hover over the bottom ruler, the snapping happens to tenths of a second. When I hover between tracks or on the top, no snapping. The last thing about timeline is that it has cables on the right, and those cables can be reconnected to other objects. So if you record a macro but you want to switch how it works, you can do that. In the future, I think there will be more editing capabilities within timeline. Right now, this is all it can do. Next in line is hotkey. I cannot really say much about this one. It's just a hotkey. It uses the operating system's global hotkey functionality to register specific hotkeys. One downside of hotkeys is that they block specific key from working system-wide. So if I set it to space, now if I do it like that, no other program can receive space button. Space is now completely hooked by Automat. The only the workaround for this is the humble key toy. It's not as hot, but it plays nicely with other apps. I've already shown how the monitoring works. I can hook the space and it will react to space without hooking this action. The key object it's the same that macro recorder and timeline use. So if I press some keys, oh, it crashed again. So macro recorder and timeline, they will also use the key toy to represent key presses. So next we have the mouse toy. It has a nice mouse face on the bottom, and the side buttons look like mouse paws, so or ears or whiskers. They have something micey about them. The only goal for this toy is to hide all the other mouse-related toys. Otherwise, we would have 18 different mouse-related objects. Mouse move, there are 2 mouse scroll objects. Plenty of, just a ton of them. Okay, now it's getting weird. That was another crash, by the way. So without this mouse object, I have basically 2 ways to implement this. I could have designed a unified mouse object that would be able to capture the utility of all of those 18 different objects, or I could create 18 different smaller objects focused on one functionality. And this proper design of a single unified mouse object that would be able to do all of those things at the same time. It's possible, but it requires a lot of time. And I think it's just safer. It's probably a safer way to design smaller, simpler toys like that. One of the advantages of those basic, simple toys is that I can put more time towards polish rather than designing a single complex device. So this one has this cool feature that when I zoom out, it tries to stay readable. So you have to kind of look closely, but it actually moves the icon to the center of the toy so that it stays readable even when you zoom out. I think if I designed a single unified mouse object, it probably wouldn't be able to provide this, those small niceties, those small kind of pleasant surprises. Next we have the number object. Number toy, it's obsolete. It has no function, but this is also the first toy that I've added to Automat. The story behind this one is that when I started working on Automat, it was actually not focused on game automation. I was trying to go through the 7GUIs benchmark. 7GUIs, some of you may be familiar with this. This is a really cool way to compare languages. It's a set of 7 example programs of increasing complexity, and they can be implemented in any language to see how a language handles complex GUI problems. With Automat, I went to this level, CRUD, and then I decided, okay, that's enough. We can switch to game automation now. And number toy, I'm keeping this as a keepsake. It was useful for going through those 7GUIs benchmark. Next, probably eventually this number toy is going to be useful for other things because there are a lot of places in programming where you need math, so it's definitely staying. After number, we have an interesting batch of toys. We have a deck of cards and a square with Broadway lights. Those two objects are they are closely related. And there are hundreds of cards here. Together they are a mechanism for controlling Automat in a more sophisticated way. Their iconography, or like the symbolism here, is a reference to Monty Python. The roses, the flags, the Broadway lights, all of this, even the creepy cutout pictures, those are all Monty Python references. So let's look at the instruction library. On a modern CPU, you will have more than 1,000 instructions. There are plenty of duplicates, instructions that have maybe slightly different encodings or different variants. They happen to do the same thing, they only differ in their length or how they are, basically only differ in their length or the type of arguments that they take. And those instructions, they can also be parameterized in a lot of different ways. So to sift through this mess that, assembly programmers have to remember, there is this toy. The instruction library is meant to help with this. It has categories on top that you can use to select a specific type of instruction that you are interested in. And you can also select registers. So this filter allows you to select a register that you want to read and a register that you want to write. And now it parameterizes all of the instructions in this way. So I can have instruction like that. Registers are symbolized by different icons. There is axolotl for AX, box for BX, circles for CX, dolphin for DX. Those icons have been chosen because of the letters for words, like in an ABC book for kids. And I like this because it kind of makes this assembly, it moves this away from expert programmers into something that, kids that cannot even read can, it kind of takes all of the professionalism away. So This egg and gravestone, those are the symbols for source and destination registers. They use more abstract symbolism. Anyway, the assembly present in Automat is a very narrow subset of actual assembly. It's missing like 80% of available registers. There are no floating point instructions or registers. There are no vector instructions or registers. There are even no instructions that would access memory, but even despite all of those limitations, there are still like 417 instructions. And each of those missing categories, like floating point, vector, they will eventually come, it's just they haven't been a priority. There is a lot of complexity in instruction library, so it needs some careful design to enable all of those extra functions without making this, just a mess. Even this filter here, this is not how it's going to work. Still needs some work. But let's talk about instructions now. Every instruction has an English description. Ideally, those instructions should really have ideograms, not English text by pictures that show what they do. But text isn't so bad that it was just faster to just create text for 400 instructions than create, dedicated language of symbols and iconography to convey the same thing. On each instruction card, you have the machine code in the bottom right, and there is equivalent assembly in the upper left. Now, next is assembler. This is the square with lights around it. This is where register values are actually stored. I chose this design because there are just too many registers to show, and this way of showing them is pretty flexible. The registers which are not used can be hidden. So if I show a register, it will fly in from behind, and if I hide a register, okay, it didn't fly out, it just disappeared, but that's the idea. The registers, if they are important and I want to use them, I can pull them out and I can place them in a way that's meaningful to me. They have checkerboards on them. The checkerboards have flags to symbolize the position of bits which are on or off. The order of those bits, this is actually a very interesting thing. So the least significant bit is on the bottom, the most significant bit is on the top. And this is because how programmers like to talk about bits and bytes. Like low bits and low bytes are at the bottom. They have the lowest value, and high bits are on the top of whatever. And it's funny because programmers don't really use visual metaphor for programming, but they still use this language that conveys spatial relationship between bits and bytes. Another example is the shift. For example, this multiply by 2, right? Do you know how programmers call this? The programmers call this shift left. This is why bits go from left to right. Like the least significant bit is on the right, and the most significant is on the left. This is because, that's how even programmers have this subconscious graphical 2D representation of values, and this is how things are ordered in this subconscious spatial relationship of numbers. Okay, so on the register, next to each register, you can also see some hexadecimal values. This hexadecimal values use a special font. The meaning of this font is hexadecimal. So if you see something in Automat that uses this font, it's hexadecimal. And just like almost every toy in Automat, registers are not quite finished. So there will be some more text here to show the decimal value of a register. And on the left side of a register, there will be place to put the Unicode text. I said text, and text is not something that usually goes together with registers. This is because in Automat, registers can be used to store text. It may seem weird because in most languages, register is not just enough space to store text. But if you are doing game automation, you are never really processing large chunks of text. It's usually very short sections, like names of items, names of locations, values of your character statistics, and so on. So 8-byte registers, most of the time, it's perfectly fine for string storage. And if you have vector registers, we can actually store quite long strings here. So that was assembly. Next is window capture. Window capture is just a window. It's using the Luna theme from Windows XP. It's just a pretty theme. It feels a little bit more friendly than flat design. So if you compare the window border that I have, this is the default GNOME theme. I just feel this old Windows XP theme is more, I guess, friendly. This toy is super straightforward. You point it at a window and you run it, and now it's going to capture that window. It's going to capture that window and store it internally as a bitmap. There is only one toy in Automat that uses those bitmaps, and this is the OCR toy. Okay, maybe I will slightly change how they work. I will insert some delay because this, if I leave it like that, it's actually capturing the window at a very, very high speed, way faster than even the application can generate those bitmaps. So it's like capturing the windows at like 500 FPS. Okay. And maybe I will even switch the window that I'm capturing to this one. What's up with that? Okay, I will restart Automat. Sometimes it does those funny things. Okay, am I hooked up? Okay, I think I know. Yes, so it was, I actually had this window at a split screen, so it probably, the window manager probably allocated 2 different buffers for the window. Anyway. This other object, this is called Tesseract. Tesseract allows you to select a region on the image, and maybe I will delete this. Let's grab a fresh one. You can select a region on the image, and it's going to perform optical character recognition in this section of the image. See? So timer is directly inspired by blah, 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 blah. The design of Tesseract is an homage to the underlying library called Tesseract OCR. The design includes an eye, and this eye is a way to indicate where Tesseract is looking. So if I had 2 windows, like one of them could show Automat. Whatever, started. It will actually move left or right to indicate from which bitmap source it's capturing the bitmaps. And when it is capturing text, it will actually, the eye is actually going to look down at the text that it's capturing. So let's run this. So the eye, yeah, it's a little bit twitchy now, but you can even see that there is an animation for the OCR process, because the OCR, the Tesseract library, gives some feedback. It's a long-running job. It happens in parallel in different thread. So this scroll that you see here, this is actually a feedback from the underlying library doing OCR, and you can see the progress of the OCR process. So this Tesseract, it's using, again, quite a few metaphors. There are hieroglyphs. This is a metaphor to some kind of language that can be read, like mysterious language. There is a blur in the background. The blur is a way to say that, hey, this section is actually not going to be part. Like the Tesseract is not going to read the blurry part. So yeah, this is the way to handle text. And you can output this text into a register. So yeah, it's going to, if you actually decode those ASCII characters, this will be probably the initial letters of timer or something. Timer is 20, I remember this one. 20 is a ASCII for space. So this is this space character. Yeah, now we have CRUD. Okay. Now, last but not least, we have the Automat development kit. This one is shown as a box. It is loosely based on the Operation board game. It has some labels and stickers with cues about its contents. The only option offered by this toy is called extract files, and by this point you may guess what it does. So for the reference, this is the directory where I'm running Automat from, and when I call this extract files function, it's going to populate this directory with a bunch of files. Those are sources of Automat, and if I do this, I can actually invoke the built-in script so it's going to build Automat from sources embedded within Automat. So it actually contains everything you need to, let's say, to tweak it and rebuild it yourself. The script obviously contains, Automat obviously contains its own source code. It also contains documentation, design documents, and there are scripts that currently it's downloading the dependencies for building Automat. So the goal of this toy is to allow any user of Automat to tweak it and hopefully, maybe possibly upstream their changes. This toy is in very early stages, but it's also the place where I hope to put other utilities for working with Automat, like some utilities for working with shaders. For instance, working with shaders is such a pain where I have to go through the compile, run, and this compilation loop is just super slow. Shaders should really be developed interactively. Okay, so we went through all of the objects in Automat. With this, we have concluded our tour through the surface. Now we're going to descend into the technology underneath, behind the Automat. Let's go under the surface. So the first thing we see under the surface is that the entrance to the caves is guarded by a rat. This is a diseased rat called Keith. He is the unofficial mascot for the C++ language. This is because Automat is implemented in C++. Luckily, Keith is not a major obstacle. One of his legs was blown off, so he will not chase us. So we can proceed further. In the next room, we can see this is the storage room. We can see how Automat stores the data. So this is the save file used by Automat. You may look at this and think, yeah, it's JSON, obviously. JSON is obvious. But there was a lot of thought behind this choice. There are many options. Each of them is basically faster, more compact, and easier to integrate. JSON, if you are writing native code, is pretty much like serializing to XML. But it is an important decision because JSON ultimately is I guess it's the easiest language for people to tweak and read, and it's also easiest for other programs. So by looking at this, you can probably guess, and if you tweak this save file, you can probably tweak the state of Automat. I wanted to mention this because this choice shows that interoperability is more important than speed, than memory, and development velocity even. Next thing underground is the rendering. We are going to see some Vulkan pipelines. So how can Automat draw so many complex visual effects and still run? It is crashing, but only some of the time. So first, I will show you a glitch, actually. What's this? I don't know. Let me show, for example, this register, hook this up, hide it. Okay. So what can we see here? I have this group of objects, and look what happens if I drag this one around. Whoa, the connection is very stretchy. It's not like how connections typically look. And if I pull it even further, you can see it's split. Now we have like two connections. This is a rendering glitch, and I will explain why this happens. So the way you render stuff on like modern GPUs is that you have to break what you see on the screen into many different steps where you compute many different textures, and then you assemble those textures, those bitmaps, together with shaders. So we have a hotkey object here. We start by rendering the leaf textures. So first, Automat renders a button, this power button here. Then it uses this power button texture and the textures for each other button to render a texture for the hotkey. And then it's using this hotkey texture to render the texture for the board. And then it's using the texture for the board to render the texture for the window. And then it's shouting to the operating system, okay, it's ready, you can refresh the screen now. And it has to happen very fast. So this whole work, you don't really do this on the CPU. What you do is you construct a graph and you send this graph to the GPU. This is called Vulkan pipeline. And once you send it, it is out of your hands. You do not control how long it's going to execute on the GPU. So the only thing you can do is maybe ask the GPU, so are you finished? Or like, how much did it take? And the whole art of high performance graphics is about making sure that everything you are drawing is always going to fit in the 16 millisecond budget, so to render at 60 FPS. If there is a problem, like GPU is busy or it's doing other things, or the pipeline is just too much to render in 16 milliseconds, you will lose frames. So the way that Automat renders UI is that it tracks how much time each of those jobs is taking. And it's usually a lot. Like all of the objects on this screen, they will probably together take something like 1 second to render, 1 second. So what we do is we do not redraw the whole screen. We only redraw as much as we can. We pack the frame with enough widgets to fill the 16 millisecond budget. And for all of the other textures, we just use the old ones. And this is what's happening here. This connection here, it's a mechanism that Automat uses. It's called compositors internally, but the idea here is that we have some piece of logic that can take the old texture, so this is the old texture for the connection, and old position for the object, and the new position for the object, and then it's stretching the texture to match the new dimensions. So none of this is rendering at 60 FPS, but it's just a trick to make the UI very responsive, even when Automat is actually rendering very expensive operations, very heavy. There is a lot of heavy computation happening here. So it's not perfect, but it still helps with latency and responsiveness. It even allows the renderer to be a little clever. So if there is an object that I'm dragging, I can tell the renderer, hey, this object is high priority, so make sure to always pack it in the frame. So, dragging is very low latency. And there is a graceful degradation that will happen if there is too much stuff happening on screen. But this graceful degradation also has this nice effect. So if you know animation, there is this thing called animation on twos or animation on freeze or force. This is when you do not update the stuff on screen every frame, but every second or third or fourth. And this is how Automat will degrade as well. So things will still stay kind of smooth. They will just switch to a stop motion animation. Okay, so this is how it's hard to trigger this stop motion animation. There are no easy ways to cause consistent performance problems, unfortunately. So this is how the rendering works. Let's continue descending underground. In the next room, we enter a cave with a chamber with a ring of statues arranged around a bonfire. The statues, they are motionless, But because of the blazing fire in the center, they cast shadows on the walls of the cave. And those shadows, they constantly move, they shift. So this is how Automat handles animation. The main idea is to separate the toys from their shadows. In Automat, no toy is actually animated, like nothing. All of the toys, they update their state instantly. But each toy has a shadow. In Automat, this shadow is called a widget. And a widget is the part of the toy that cares about how things are animated on screen. So this shadow of a toy, it follows it, but it follows it smoothly. So it can have inertia. It will chase after the toy by accelerating, deaccelerating, and eventually stopping exactly where it needs to stop. So widgets in Automat, they look at the state of their source object and they move towards this destination state. Widgets are free to make their own choices when it comes to animation. Sometimes they approach target linearly, sometimes exponentially, but sometimes it's using even more interesting ways to approach it. One important thing is that all widgets eventually go to sleep, like this sleeping parrot. They do this once they perfectly match the state of the toy, and this is done to conserve the energy so that I do not redraw the textures constantly. And there is a couple more toys to this animation, but they're not really very closely related to Automat, so I will instead point you to another presentation that I've done on this topic. Okay, I will hide myself. Okay, I hope you can still see this. So this is a slide deck, but with the context that I just gave you, you should be able to decode everything that you see on that page. So there is one more thing hidden in these shadows. And the secret, this one more thing, is the name of this. So in the Greek language, shadow, the word for shadow is skia. And this is also the library that Automat uses to draw its GUI. It's amazing. If you are using HTML Canvas, you are already using Skia. Skia is one of the things that actually makes Vulkan graphics usable. Okay. So ahead of us is the final stage of our journey. Okay. There are many ways to compute. We can follow like imperative style with its side effects. We can try to model computation mathematically as type systems with functions of functions. We can weave computation as reactive data flows, as actors sending messages, as inference engines processing facts, as cellular automata, as networks of logic gates. There are so many ways to compute. And people before us, namely Church and Turing, in their thesis, they postulated that computationally, each of those ways to compute is equivalent with others. Modern complexity theory, it says the same thing. All of those approaches to computation, they can only differ by a constant factor. And for exponentially accelerating computers, constant factors make no difference. In the end, it doesn't really matter which approach we choose. We can choose whatever we want. The most convenient or most interesting way to compute. This conclusion, this is maybe the only logical conclusion. It can be liberating, but it's also kind of disappointing, and I do not quite believe this to be true. I think that among all of those representations of computation, there is a special one. This representation is unique among all of the others because it's not translated, so it doesn't lose anything in translation. It's not emulated because this is the one that's emulating all of the others. the lowest level representation, the imperative language of instructions and procedures running on multiple cores, accessing shared virtualized memory. This is how computers really work. And this is what Automat strives to emulate. It strives to interface with this part. So we have toys that represent procedures. We have simple control flow. We have buffers held in memory. And we have handles to remote and abstract objects. Those are the building blocks, the most basic building blocks of virtually all modern software. Together, they are also the keys to interoperability, universal and even adversarial interoperability. These building blocks, I think they are the most stable foundation that is never going to fail. You can express almost any type of computation using those building blocks. And they have been forever locked behind bureaucracy of programming languages. And I think that the end of this bureaucracy is now at the horizon. Those simple building blocks, there have been many attempts, and this is another attempt really, to reify them into graphical user interface. And this is really the core idea behind Automat, to reify these abstract programming concepts as tangible interactive toys that you can play with on screen. Okay, so during our journey, that was the whole tour of Automat. So we've seen the North Star, we've appreciated the beauty of its surface, we've descended into not so beautiful technology behind it, before arriving at the core idea behind Automat. Now that the guided part of the tour is over, we can talk about whatever you want. So, time for questions. I can start actually because before this presentation started, there was a mention of Witness. And, there are tons of types of games. Witness is a very special one. Witness is this kind of game where the rules of the game, they shift kind of as you play through. So this is one of the games that's it's not playable to automation at all. Because as you explore the game, you have to learn more about the principles behind it. There are lots of games like that. But the category of games that I like the most, that I think is going to be the most fun to explore, are the strategy games, where you have to simulate, you have to explore some kind of state, like predict state of the game many moves ahead, and then choose one of the strategies. This is something that cannot be done with Automat. Whenever I do this, I usually use Python or C or something like that, because it requires kind of traditional programming to simulate a game. But eventually Automat is going to get there.
Yeah, that's an interesting thing, is handling control flow, handling decision making in some sense is a aspect that we didn't see in your demo today. And I'm curious, do you have thoughts about how you would like to approach that? Yeah. At least at the toys level, because I know in your assembly level and register editor, there's probably ways of doing jump if greater than 0 or whatever, but that feels too far to remove.
Absolutely. So you are spot on. So the way that you typically automate those more complex games is you have some kind of representation for the state of the game, and rules of the game, they control the evolution of this state. So if you want to play a game, if you want to build a bot that's going to play any game in an intelligent way, it has to explore the potential space of the game, something like reinforcement learning does. But if you have a game, like even simpler game like Sudoku, you can put a number, and you can recursively explore how Sudoku is going to roll out as you choose different paths. So the way that I expect Automat is going to handle this is it is probably going to have some objects that will encode state of the game. It will probably have some features for you to define how the state of the game evolves. And it will probably have some other objects that will represent different search algorithms, like maybe you want to search this in some kind of stochastic way, some beam search. Maybe you want to apply some simulated annealing or like anthill colony optimization. Right? Lots of different techniques for search can be applied once you represent the state of the game as this tree where you have a state, you have a sequence of potential moves, and each of them leads you to like a mutated state. So yes, it's probably not going to be using this very low-level assembly procedural thing. It's going to use a different metaphor.
Cool. There's a question in the chat. Does this interaction model scale to multi-pointer, multi-touch, multi-handed, multi-user interaction?
Yes, yeah, it does. Like this is one of the actually design goals to make it possible for many people to work in this space together. There is a lot of multi-threading stuff happening behind the scenes. Like the UI is running in one thread, the computation happens in the other. And multiple UI threads could theoretically connect to Automat and, I don't know, display their own windows and interact with whatever is happening on screen. So if I can move this object. I can, for example, grab this object and with, for example, my other mouse button, I can iconify this. So it didn't break. It's kind of handling kind of concurrent operations. It's trying to handle them. I mean, yeah. It tries to work. It tries to allow multiple users to use it at the same time.
Interesting. A question I've always had when looking at Automat is wondering about your your creative process on the art side of this project, because there is a tremendous amount of visual art that goes into this project. And I'm curious, like, is some of it AI generated? Is all of it hand painted? I know some of it's done with like shader code. I'm curious if you could talk a little bit about like how you approach building the art assets for Automat and what combination of techniques and tools and what your process is like.
Yeah. The most painful part about design is that it evolves. Like whenever you design something and when you implement it completely, you always see some deficiencies. There is always things to fix. But the way that I approach visual design is I use AI image generation model. I use Stable Diffusion, I use Flux, I use different models like old ones and new ones. If you get into this field, it's actually pretty deep. That different models, they totally have different strengths. So I can show you some older, what was this? Macro recorder. Like that was, for example, a design for macro recorder, which used AI generation and it used, so AI has generated like 20 different images for me. And out of those images, I created a collage that then I passed back to AI for some teaming. Then it produced something like this, which looks, it was like a long time ago. The image generation models weren't as polished back then, but they were very creative. And then out of this final version of macro recorder emerged. You can even see some of the individual images that Stable Diffusion generates. The key thing about using image generation is to do not prompt it with what you want to see. So this term, it has been kind of stolen by vibe coding, but with image generation models, the way you want to prompt them is you want to prompt them with vibes and style and avoid specifics. Because if you tell them, hey, I want to have a bird, it's going to lock on this bird idea and it's only going to produce birds. So you want to use very vague words like eagle-like. Okay, eagle-like is not, you can use Latin, you can use different ways to confuse the AI to avoid producing something which is too bird-like. This is kind of like, this is mostly image generation based on vibes. But then you combine all of those. I love some of those designs. I mean, look at this. This is just incredible, what AI can produce. It's nonsensical, so it has to be kind of still processed by a human to actually select the pieces out of this AI generated, hallucinations that actually make sense and that are consistent together. But this is the flow. And even if I have a toy that is already designed and I want to tweak something about this, AI is also very useful here because I can screenshot the toy, draw the new things that I want to add, and have the AI model kind of integrate my new design elements with the old design. So AI image generation is super fun.
Do you have
there is a lot of...
to?
Go on.
Oh, sorry. I was going to say, do you have to use that sort of screenshotting, painting on, kind of reprompting to get it to fix things like the lighting direction or the way that it casts shadows or like background details? Like, I'm curious how you go from the AI generated concept to something that works as a texture that you can use in your rendering pipeline.
Yeah. I use Krita. Krita is a graphics editing tool and it has incredible AI integration. So if I fire this up, for example, here is the design for mouse. Here is the design for the development kit or other pieces of Automat. And typically, I put in the prompt, I put the description of the environment. I say, hey, this is a top-down orthogonal view. This is a product photo of a toy. And I describe the lighting in the prompt, so the model follows that. When I do incremental edits, I don't even really need to do this because the model is clever enough to infer the lighting from the rest of the image. I can just select a section. For example, I can select a section here and I can tell the AI model, it's not connected to any API, but I could ask it to regenerate, for example, only this fragment of the image, or I can tweak this manually. A graphics editor integrated with AI tooling is instrumental to this.
And then another big component of the art are your animations and your shaders and that. And I've caught some instances of you working and iterating on those shaders on your live streams that you do. And that's always really fun to see. And so I'm curious how you decide when to build something as a static art asset, when to like use an AI prompt and do some editing with it to get that, versus when do you reach for a shader that you're, creating in that style? Is it just purely down to like when it's animated, it needs to be a shader, or is there another dimension to the choice?
Yeah, there are some places where animation is not really based on shaders. Some of this animation is really based on just images being stretched and moved around or like wiggled on screen. So in terms of techniques, I'm using whatever technique fits the specific element of the design. There's really no big... I'm not dogmatic about picking any design approach, any animation approach. I will use whatever is best to achieve a given effect. But I think long term, probably 3D graphics is the way to represent objects, because as the interfaces kind of shift, I think in a couple of years we could all work in VR, and I think VR is more forward. 3D art is probably more forwards compatible with this VR world. So I think eventually I will have to redesign everything as 3D models.
I love this at live. I love this now. I could just lay superlatives on this forever. So I'm just going to skip that and say this is amazing. One thing that really evoked my imagination this time, and this connects into what we were just talking about, was like the tabletop perspective and like the toy perspective, which immediately causes me to connect this with like dynamic land and like folk computing-esque stuff. And it makes me wonder about like toys and introducing new toys into the system, and like in connection with this, like I look at the skeuomorphism here, and like I'm curious whether you agree with this or not, but like I feel like that there's kind of like three different categories of how skeuomorphism is being used. Like one is like peripherals, like things that look like the things you actually interact with, like the mouse or the keyboard or whatever. The other one is like things with pretty direct metaphors to real world objects, like the stopwatch. Like the stopwatch basically does what a real stopwatch does. And the third category is stuff like a lot of the assembly stuff, where there clearly is a metaphor, but it's like a metaphor. Like it's not like this
Yeah,
thing is this
yeah.
thing. And like it strikes me that, the peripheral category is one that like I could imagine the system where like say, if you were using this in a dynamic land kind of thing where there was a camera above, you could put like your mouse on and it would take a picture of your mouse and like you could interact with it in some way and it would correlate that with the signals. So like, you could have an interface for kind of creating tools in that automatic way. And I mean, I don't know. It causes me to wonder whether you could even do that for stuff of the second category, like stopwatches or whatever, like semi-automated or semi-automated ways for like bringing real-world objects into this space.
Yeah. Uh, the real world objects are tricky because if you look around in the natural world, and by natural world, I don't mean the world of technology, I don't mean the world of stopwatches and so on. Uh, there are some kind of universal metaphors that are probably familiar to all of the people, regardless of whether they have encountered any technology at all or not. But they are kind of, they do not work for interactive computational stuff. So, for example, if we contacted a tribe, like Amazonian tribe that didn't have contact with any civilization and gave them some kind of computational device that they could use, they would probably be very confused by any references to technology, but probably every references to the natural world, like the animals, everything made out of wood, those devices that, you could see around you, those would be much more familiar. And skeuomorphism, it works for simple things, but for more harder computational things like the if condition, there are really not that many things that you could base your metaphors on. So it's very tricky to find them. Yeah, there are cards, there are train tracks, there are water pipes, all sorts of metaphors that you could explore. But very few of them actually work for general computation. But yeah, I agree with what you're saying about three types of skeuomorphism. One of them is very superficial, one of them is about emulating the function of devices, and one of them is like very metaphorical. Yeah, that's true.
I think we have time for probably one more question if anybody has something that they're burning to know about Automat. And of course, if we want to talk more about Automat, which we inevitably will, come join the Slack. If somebody's watching this on YouTube and you don't know about the Slack, go to feelingof.com. There's a whole bunch of interesting programming things happening in our community.
Do you find that when you're developing automations as you're trying to navigate different games, are you building kind of collections of toys and then like reusing those, like they become abstractions that you reuse? Or do you find because gameplay can be so unique that you are kind of using the macro recorder and a collection of toys and building bespoke um, solutions to each application you're exploring?
Yeah, I actually use Automat a lot to play games myself. And whenever I switch between games, I always notice some deficiencies, like things that can be improved. So this is my process is I pick a new game, I start playing it, I notice the repetitive parts of the game, and then I try to automate them. And I guess the current set of tools that are available, this is pretty much good enough to automate most of the games that have some kind of manual repetition. But it is absolutely not enough to play games that have some kind of higher level, character control, where I would need to create a bot that will, navigate the world, interact with different characters and do this kind of stuff. It's still not there. I guess I will be slowly adding more toys to make this possible. And I think it will take still quite a bit of time before it's it can play, more sophisticated games. The games that I played so far, they are mostly focused on simple macro repetition. So for them, it's pretty much sufficient to have something like this.
Well, this is really cool. Thank you so much for sharing with us.
Yeah, like I think the next frontier will probably be reacting to enemies in games, because in combat games or all sorts of like shooting games, you often have this thing where the game gives you a cue, like a sound or a visual cue, a character making specific, pose, and you have to dodge or do something like this. So I want to apply some visual kind of image recognition algorithms to help with that, so that Automat hopefully can recognize those visual cues in a game and automatically press a key for you if they happen. For Dark Souls and games like that.
Well, Marek, this has been breathtaking. Thank you so much for showing us how Automat works and how you built it. And for anybody watching this who would like to keep up with Automat, the website is automat.org, I believe. Yes, automat.org. And Marek also streams development of Automat on Twitch, which is at twitch.tv/MAF_PL. And there, VODs are posted on YouTube, and there's other updates elsewhere, but the automat.org website has links to all of those places. Anything else you want to plug, Marek?
Yeah. Automat is coming to Steam, I hope soon, but you should check automat.org. I will put the Steam link and Steam pages on automat.org. Yeah, just put this in your notes, check this in a month, and I hope that in a month the Steam page should be up.
Yeah. And if you haven't seen automat.org, the website, you should go there. It is appropriately built, considering what it's about. It's a very good website.